Thank you so much, Phil, for joining us today at BI Consulting Pro. I know you are being quite busy, and it's really a pleasure to have you all here. How are you doing today?
Good, thank you, and thanks for inviting me. I'm always happy to set aside time to talk about my favorite topic, which is DAX,
Yeah.
especially optimizing DAX. So, thank you for inviting me.
Of course. So we are recording this session so that everyone can watch it at their own convenient time. Once again, really thank you for making some time for this one. And I really believe that this is going to help a lot of people out there who are working with Power BI and DAX. All right.
Yeah.
So here's your presentation. And it would be good if you can just start with some of your introduction to the people.
Sure.
And then we'll...
No problem. So my name is Phil Seamark. I work for Microsoft on a team called Fabric CAT. CAT stands for Customer Advisory Team. And this particular team spends a lot of time with large enterprise customers who use Power BI, inevitably with very large data sets, lots and lots of people, complicated visuals. And when they need help, when they need someone to just come in and help them tune, help them figure out what might be going on, then quite often it's either myself or someone from my team that get involved. Inevitably, when we get involved in those engagements, which I really enjoy, we always learn something. I always learn something. So it's opportunities like this session where we can share some of that knowledge out. And hopefully if someone is watching this, they might find just one nugget of gold which helps them in their day job tomorrow. So that would be pretty cool. I am going to be doing some pretty low-level technical DAX. Now, don't worry about every single item of syntax. It's more the concepts, it's more the strategy, how I use community tools like DAX Studio in my day job to go and look for problems and how I can use things like that to test and optimize. So, that's probably the main takeaway that I'm hoping that you might get if you watch this video all the way to the end. Try and stay awake.
Great. Thank you so much for the quick introduction. So here now we are eagerly waiting. So what's today in the box for us?
Cool. So shall I carry on? All right. So optimizing DAX Studio. Agenda. I don't have a big agenda here.
Yeah.
We talked about DAX Fusion. So hopefully you've all heard of DAX. If you're using Power BI, it's hard to not use DAX. But we're going to be focusing on something in particular called DAX Fusion, which is not so well known. And it's very important when it comes to help very slow reports run faster. The more fusion we get, generally the faster the reports, the visuals will load. And I've got an optimization exercise, which I'll try and whiz through, because normally I spend about an hour on this, but we'll see if we can get this through this a little snappier. And we've got some summary points at the end as well. So I think, first of all, probably what we want to do is just have a look, what is Fusion? When I say DAX Fusion, what does that mean? And there's a couple of flavors of Fusion. There's regular Fusion, which has been around for quite a while. And then more recently, we introduced a new version of Fusion called Horizontal Fusion. And I'm going to show you a little bit about some of the challenges that we encounter along the way. So first of all, let's run some DAX queries.
Yeah, indeed. And that would be the best part.
So I am presenting my screen. So hopefully you can see my screen. There's a little bit of a model here. And I've got an AdventureWorks model with a fact table down here in the middle, surrounded by some DIMs and nice star schema. It's not a very big model, but I just want to point out the fact table in the center here. I am running in direct query mode, deliberately just so it makes it easy to spot how often we need to talk to this table when we're doing some simple things. So just want to introduce the model to you. Don't worry about studying the model too carefully, although we will spend a bit of time on the exercise. So first of all, let's connect to our model and have a look at some DAX queries. So if I go to my after and connect, and let's have a look at what regular Fusion is. And I've got a DAX query here. Hopefully this is coming through pretty nicely. And I'll turn on server timings. If you haven't seen this particular tool, it's called DAX Studio. Fantastic for debugging, optimizing queries that you can extract out of your semantic model or Power BI desktop. This query here is pretty straightforward. What we're doing is grouping by this column in this table, the brand name column in the product table. So by passing that as our first argument in this function, it's saying, just give me a list of every unique value that happens to occur in my brand column. And then for each one of those items, we're going to go work out what sales are. It's going to give me a result with two columns. I'm not so worried about the result. What I'm interested in is how does the engine inside the model go about arriving or delivering that result. So let's run the query and see what happens. I've got this connected to a localhost SQL server, so possibly waking up for the very first time, because normally this is pretty snappy. In fact, what I may even need to do is just stop and start my SQL Server.
Yeah.
Because I haven't restarted my machine for a little bit. Just find my services. Okay, this is, and just in the background of the screen, what I'm doing is I'm just pausing and restarting my localhost SQL Server, and then we should be good for the rest of the session. Just waiting for that to come up. I mean, it might, I wonder if it'll wake up here. No, it's still waiting for me to stop and start the session. Okay. Going down, good old fashioned SQL Server. Oh, start it. It's starting.
So Phil, why do we what was the reason that you selected a direct query model for this one?
Oh, and it's going to become obvious because when we run the query, part of the server timings tells us when it's querying an import table and tells us it's a scan versus when it's running a direct query session. And this is still taking something. My SQL engine has started. Once it wakes up, it normally is quite quick, I promise. You might want to cut this out of the recording.
No, it happens. To be honest, I always face these situations at my end too. But it's fine. Yeah.
We're away. We're good now. Okay, so just the demos. The demo gods were teasing me a little bit here. So we have a result. I'm not worried about the result. Just believe me, trust me, these are the correct numbers. Telling me it took 33 seconds to run that query. Now it didn't really, that was just my SQL Server running, waking up. So with my clear cache unrun, I'm going to rerun it now, and it should be only a couple of 100 milliseconds. No. All right. So, but what I want to focus on, unless you want to restart, is this query is nice and simple. We're grouping by brand, and we're doing a sum of sales. So down here in the XM SQL, what we can see here is the underlying query that is generated to go and get the data we need to deliver the results to this query. And we can see if you're used to T-SQL like Dilect, that we're grouping by brand name. And then for each brand, we're doing a sum of sales amount. That's pretty straightforward. Okay. So now what we're going to do is not do sum of sales. I'm going to replace this query with a slightly different version called, which we're grouping by brand name, but we're going to sum quantity now. What's going to change is rather than sum the sales amount, what I'm expecting to see if this runs in a second is...
and also, Phil, when we check that query on the side window, it says top rows over there. I think it's 1 million rows or something.
Yeah,
so is it the maximum of rows it always count, or it's just take random like 1 million or something rows from the top?
Yeah, that's sort of the engine injecting that just to make sure that we don't get more rows than we actually need. I don't have that anywhere in here.
Yeah.
But notice here in the same query now, we're still grouping by brand name.
Yeah.
But now we're summing by sales quantity. And that makes sense. We only need to do one round trip to the storage engine. Now let's hit the third version of the same query. Okay, cool. Now, in the old days, what would happen here is this query here would actually make 2 trips to the storage engine. You'd see 2 events down here. The first event would look like the first one we ran, the second one would look like the second one we saw. But here, the engine has been smart enough to combine the 2 aggregates into the same query. Now, this is what we call regular fusion. Because we're grouping by brand name and then we're doing the sum over the same fact table, there's a lot of simple characteristics about the task required to go and get what we need for this measure and then also get what we need for this measure. So when we hit play, this piece of text, which is the query, goes to the engine produces a query plan. The query plan is probably quite complicated and doing lots of unnecessary things that are repetitive. We pass over that query plan and we try and simplify it by saying, hey, let's not do this task over and over again. Let's do it once, use the results, and even let's modify that task to combine very similar looking type tasks to, so that's regular fusion.
All right.
So we want to
So
introduce.
we need to do something like when the users, for example, a Power BI developer, he wants to optimize the code and he wants to take advantage of this Fusion, DAX Fusion.
Yeah.
So do
So
they need
for
to do
regular
something
Fusion, not so much.
specifically? Okay.
Yeah, so for regular Fusion, it just happens. But what's helpful here is to know where to go to look for it to make sure it is in fact happening. So what we're hoping is that down here in the server timings, we don't have lots of unnecessary storage engine events. We've only got the one. And even though we're introducing two completely different measures that are hitting the same fact table, that we are still hopefully only seeing one. And this might be a bit clearer now that when I show you the horizontal Fusion version of this.
Yeah.
So I'm going to give you a fourth query here now. And if I scroll back a little bit here, I'm still grouping by brand name because we're going to be consistent here. And what we're asking to do here is add a couple of columns to my result set. The first one is going to be called red sales. The second one is going to be called blue sales. And you can see in my DAX query that I've said I want to calculate sales, but filter where the color name is red for line 5 and blue for line 6, etc.
Yeah.
Now, again, in the past, before horizontal Fusion, this would produce two storage engine events. And if we hit the play button here now, what we can see is there's only one event. We can see that event here. We click on it and we can study the structure of the XM SQL that got generated. And what you can see here when we focus on it is regular Fusion kicked in to say we were doing sales of red and quantity of blue. So that's good. But we can also, in the where clause, we have an in statement. And we can see the horizontal Fusion has actually managed to combine those together in one result set. And that result set came back with the appropriate number of rows as there are unique brands and unique colors. And then for each row of those combinations, we go and figure out what's the appropriate sales amount and what's the appropriate sales quantity. And that allows us in the result set to be able to say, okay, well, for Northland traders, here's the red sales and here's the blue sales. Look, it's really blue quantity, actually. I should say this is quantity in the column header. But the idea is that horizontal Fusion can now look at filter settings, and so long as they're similar enough, we can combine them into a single storage engine round trip to the storage engine, which what we're seeing here is very expensive because my CPU is for some reason struggling in the background. So in some ways, this is helpful. Okay, let's break horizontal Fusion. So what I'm going to do is put exactly the same query in. We're even going to do sales for both. But all I've effectively done is put an additional filter criteria on line 6. So previously, they were very similar. Like the only difference was the red and blue on the same column. But now we're going to filter on a different column. So what does this do? Okay, let's run it. It's fast. So my CPU's caught up. So we're back to normal now, which is good. Trust me, these results are correct. But the server time is telling me we've done two tasks now. We couldn't fuse them together. Let's have these two tasks. The top one is giving me, for every unique brand name, summing up sales for regular and blue. So this is actually line 6 in my DAX query. Let's click on the other one. And it's like, if I jump back and forward, you'll notice the where clause changes between the two because we can't fuse them together. So we have to do two round trips. We do them in parallel, but this can start going a bit crazy. So there is a workaround. There is a clever piece of DAX called the iterator function. Now, this is quite long. What I'm going to do is run exactly the same query, but I'm not going to use the version of sales that's in the model. I'm going to overwrite that here in DAX Studio. So if I zoom in, I'm saying instead of using the sales measure in the model I'm connecting to, which is just sum of sales amount, we're one line piece of DAX, tiny. My sales measure, I'm going to do a bit more work. And my quantity measure, I'm going to do a bit more work. And here's my actual DAX query down here at the bottom. So you'll notice I'm grouping by brand name at line 38. So that hasn't changed. And I've now introduced 3 measure columns at line 40, 41, 42. And notice these have all got differences. So they shouldn't fuse. But let's run this and see what happens. Cool. They do, in fact, fuse. Now, you might ask, okay, I can see 9 storage engine scans, not 1, not 2. I only care about the storage engine scan that has a subclass of SQL. This is that DQ one that is talking to my fact table. Imagine my fact table's got a billion rows. So I'm really, that's why I put my fact table in direct query mode, so it stands out. And in fact, if we notice the duration for these here are very fast, and there's no aggregate, there's no sum, they're not talking to my fact table. The only one that talks to my fact table is this one here. So this top query, if we focus on, what is it doing? It's saying create a table with every single unique value of brand name, but also Cartesian that off. So it's also including, you know, brand times class names times color. So we've got 10 brands and 6 classes and 5 colors. That would be 10 times 6 times 5. So that's 60, that's 300 rows.
Yeah.
So it would produce a 300 row table, and you notice the groupings by there. And then for each one of those rows, it's calculating the sum of sales amount and sum of sales quantity. So it's making one round trip to the storage engine. It's almost like I've said, if I only ever get one chance and I could craft what would be the perfect result set that we get back from the storage engine that I can then use to figure out what are the sales for red, what are the sales for blue and regular, what are the sales or quantity for yellow and deluxe. I can now use that, almost disconnect, you know, stick it in Excel and go down and figure out in the results. You know, I can get this information from that, say, 300 row table. And that can have quite significant performance benefits on systems that are running over very large data sets and running very busy. So that's introducing A, regular fusion, B, horizontal fusion, showing you the gap with horizontal fusion and showing you how you can, using DAX, solve that.
Yeah. So Phil, there's a question for all the, let's say, a kind of a beginners who are working on optimization of their DAX queries, like over here. And we talked about there, okay, you should focus on the search engine, then the formula engine over there. And we also talked about, you know, the different fusions. But how those people, like in ideal way, they should start looking at the queries, like should they go first for the formula engine or the search engine? How they should, you know, take the approach over there to look forward. And I believe, you know, fusion is quite an advanced concept for most of them, but that's really good one. And what would you advise to them?
So what we normally do is you identify what Power BI report page is taking the slowest to load. And then on that page, you identify what's probably the slowest visual on that page. So you can do things in Power BI desktop like turn on performance analyzer. And we're going to do that if we have time. And when you refresh the page, you can actually see the timings of each visual, how long it takes. And you do have to be careful because sometimes a visual can be just stuck in a queue. You know, if you've got 50 visuals, which you shouldn't, the ultimate time it takes to load is not necessarily the DAX side of things. So you can drill into that and sort by, you know, how long did the DAX part of each visual take to run. Find the slowest one, get that DAX, bring it over to DAX Studio and connect to your model. Turn on server timings the way I've done. And this is what I mean, you know, when I said in the intro, it's the techniques that I'm using here that are probably the takeaways. And then when you run it, you can see how long does it take in single user mode, you know, not competing with all those other visuals. And when you look at server timings, what I first look at is usually this number down here. How many storage engine queries does it take? And it's potentially, if that's a number like 350, that's a problem. You probably want to get that to 20 or less. I generally try and get it down to 1 or 2. And I do focus on which of those storage engine events actually talk to the fact table. The fact table is the large detail one that has to do a lot of work scanning. And then what I do is I look through those for repetitive patterns. This is now starting to get into that intermediate and advanced DAX. But what you can do here in DAX Studio, as you've seen here, is it's quite possible for you to create your own version of a measure. So not with codes in the model, you can do it here and play around with some ideas, try different things, do some internet searching and look for recommended patterns, because I guarantee it's probably been solved. One of the best places I learned DAX was go to community.powerbi.com, which is probably community.fabric.com. And lots and lots of forums where people have posted, hey, how do I do this period comparison? How do I do this running total? How do I do this child parent, you know, with what I think are my unique characteristics? And, you know, people suggest, hey, well, have you tried this pattern? Have you tried this approach? And you can maybe give it a go. And when you do, first of all, make sure you're getting the right results. And then you can have a look to see whether it was better or worse. And you can take that code, and if it's better, put it in your model. So generally, you know, I find having DAX Studio and server timings invaluable with that sort of circle, so that you can play without breaking your model. And if you're a beginner, it's definitely useful. But if you're an
Yeah.
advanced person working with big enterprise models like myself, I'm doing the
Yeah.
same thing, So these techniques can be
Indeed.
helpful.
And I believe this is really important to pay attention first whenever you try to run any code over here in the DAX Studio
Yep.
on the storage engine and formula engine, then try to reduce the queries or reduce the timings over here, and then only you can proceed forward. And
Yeah,
that's very well said over
and we
here.
talked about the two engines. We mentioned that there are two engines. The
Yeah.
SE is for storage engine.
Yeah.
The
And the
FE
formula.
is the formula engine. So the analogy I like to use to describe the difference between the two is, imagine your task is to bake a cake, and
Yeah.
the storage engine is all about going to get the ingredients from the store.
Yeah.
So, or in our world, going to get the data from memory. So what you don't want to do, if your cake requires 10 ingredients, you don't want to make 10 separate trips to the same store, and
Indeed.
it's not efficient. You want to go
Yeah.
once and get all 10 ingredients, and you want to make sure that, and the good news is the storage engine can run in parallel. So imagine you've got 10 friends or 10 kids, and you send them all at the same time to go get one ingredient. Yeah, that works, but ideally you just want to go one and get all the ingredients, because then when you've got the ingredients back, the chef can kick in. Now you've only got one chef, because the chef is the formula engine. That's not multitask, can't go across cores, etc. And the chef has to now take the data, take the ingredients, and assemble them together to make the cake. In other words, the result. So typically, if the storage engine number is really high, like in the hundreds, that's probably something that you will look to try and optimize, either understanding Fusion and solving it that way, or yeah, like I said, doing some internet searching. Pretty sure most patterns you're likely to be doing have been explored many times in various websites, and PowerBI.com is another. Community.powerbi.com is another great one as well. That's actually where I learned my DAX. I do recommend it as a fun way to just solve puzzles. Is get involved and read what people have solved.
Yeah, definitely. I completely agree with you. In fact, I also promote lots of people just to go over there. Power BI community is an amazing place where whether it's a Power BI service, Power BI desktop or text, just go there, post your queries or try to learn from the others. There are so many different questions are over there.
Yeah.
And DAX is one of the most challenging part whenever they design any Power BI report over there. In one of my organization where I was working, so there the data sets were like 40 GB, the import one. So ideally it's like 10 to 12 times more the data. And we were facing huge performance issues over there because of the DAX calculation. Those were not optimized. And most of the people, the developers over there, they said, no, we cannot optimize more than that. And I said, no, it cannot happen. Then when we start looking into this one, we found a lots of, different ways that this can further optimize. So sometimes I personally believe it's just we are limiting ourselves. There's always a way to go forward, to improve it, to try something new inside that one.
Yeah, but I sort of whiz through a quick optimization exercise just to sort of give you a feel. When I mentioned, you go to your Power BI report, the slowest page, and you figure out which is the slowest the slowest visual.
Yeah.
And I always guarantee that the slowest visual is probably going to be a matrix visual, a matrix where you've got lots and lots of measures in the columns and lots and lots of queries. It almost nearly always is that one. And the good news is we can solve that. So what I'm going to do is jump over to my deck and show you an example of before and after. So here's I haven't laid this out beautifully. I don't do good Power BI report design. This is ugly, but anyway, this particular matrix has about 5 different types of calculations. Sales, quantity, transactions, and there's a couple of other ones just off to the side. It's doing period comparison. So up here we can say whether we want to take the current month that we've selected, which is May 2008, and we would just dynamically say the comparison should be either the previous month or the same month the previous year. We can choose the brand name. There's actually a filter on the visual saying only show me the top 5 stores by sales. So there's a lot going on. And what does this look like? There's a really quick summary of what I just said, actually. But my model, which is Start Schema, that looks like this, took 20 seconds to complete. This is actually when my machine was running really, really quickly. It's around about 100 seconds behind the scenes, so it's not very efficient. And here, remember those trips to the store, 337 trips to the store. Now, without touching any DAX, without changing a line of DAX or doing anything complicated, what I did for my first pass is just fix the relationships. We can see these icons here are saying we've got BiDi relationships everywhere, and that's probably not going to be optimal. So just simply fixing that. And also, remember how I said my fact table was in direct query mode? When you're doing that, your DIMs should be in dual mode. And these ones here are currently import. So just changing these three tables from import to dual mode, and just changing these relationships to be one directional, the standard relationship, that took me to here. Similar timings, but the number of storage engine scans shrunk, and the total number of CPU seconds required to complete this, because we can spread the load across cores. It's now over half the, under half the amount of compute. So that's without touching anything. Then what I did was I went through 3 layers of optimization, and I'm not going to dwell on them. Version 1, in this particular case, removes the calculation group. Now, calculation groups are fantastic to help measure sprawl, but unfortunately, in some situations, they can block fusion. So I'm going to show you what server timings are, just simply by replacing a calculation group with a disconnected table. So you can search it, what that means by that. Version C, or the one after that, what I did was take my simple line of my simple DAX, which is just sum of column, and use that pattern I showed you earlier that we used to kind of get around fusion. So made my DAX more complicated, but we'll have a look to see what it did. And then finally, we introduced a table into the model, a time intelligence table, to finish that off. So what did that look like to the server timings? Because I don't want to spend too much more time on that. So query A. Here is my before. So this is actually it was saying 133, but this is just changing the relationships and the storage modes. This one here is removing the calculation groups. So what I might need to do is just run it actually. I'll connect to after. Connect to this and put my server timings on. I thought I had it saved actually, but this is showing you how you can connect and run it. And it's running, and so we're in the 120s with the number of storage engine events.
Meanwhile, it also leads a very important point over here to all the people who are watching this video or trying to work on the PowerBI to optimize it. Work on the data model itself, because that's really necessary, because without that, you cannot do that. So I have seen in many cases, people are making many-to-many relationships, bidirectional relationships, or their schema is somehow completely different. It's not even star schema or something. So that really helps if you are going to spend a lot of time. I always say, spend 80% time on the data modeling part or the backend part, and then 20% on the report designing. And
less DAX is better. If you can start with the data model and do less work in DAX, then you're probably going to get faster reports and it's easy to maintain, etc. So here's the server timings for just simply getting rid of the calculation group. Same result. So now we're down to 13 storage engine scans. There's actually only, if I sort by subclass, which are the, it's not letting me sort by duration, there are only 5 of these 13 that talk to my direct query fact table. And that's where the bulk of the time is spent, and the overall server compute's coming down. So this is pretty good. This is my simple measures. So now what I do is I introduce that complex X iterator pattern that I touched on before. And what this did is it got us down to 1 scan, but it slowed down. It actually made it longer, and I'll explain why. So this is good in that we only have 1 storage engine event, and that storage engine event for my matrix, all those columns that I showed you in that screenshot, all the rows, which actually were too many, we're grouping by continent, month, store key, and then for each of those 3 combinations, we're going and doing regular fusion to go and figure out the aggregates that belong to each of those. Nice and clean, but the problem with this query here, if I was to cut and paste this over to my SSMS and just run it against the my direct query storage engine, is the table's really big. Because I think I've got months that go back 15 years or something. It's really, really ridiculous, too much. But in my matrix, I'm only ever interested in a month that the user selected, the previous month or the same month previous year. I only ever care about 3 months. I don't want to have 300 months because that's going to blow out my Cartesian. So what I do in my final step is I introduce a time intelligence table, and I blog about this in my DAX.tips site. It's called row-based time intelligence. Now, let's see what happens when we introduce a time intelligence table to this. So the result now is we still only have a single fact table scan.
Yeah.
But the time is like 1.6 seconds and the compute time is less than a second. And the difference is the where clause has been introduced. So simply by attaching a time intelligence table, connecting it to your calendar table, that by nature can influence the shape of the storage engine event, and importantly, introduce a where clause. And that limits the unique values that can go into this column to just 3, never more than 3. So 3 times stores, which is 15, times continents, how many continents are there? So we've now got a significantly smaller intermediary table to work with to then post-process over in the formula engine. And that's where you can really save some compute. This is an advanced technique. This is not something you do for every visual on every report. All this is doing is showing you what you can do if you really need to go to that nth degree, and how you can use DAX Studio to connect, run queries, what to look for. There's a whole bunch of things going on here that I just want to sort of touch and introduce. Because a lot of people don't realize what you can actually do with DAX, which is pretty neat. I mean, I've DAX games like 3D maze games, and you can actually explore a map inside PowerBI, and it's just all user. And this was my friend. I couldn't have done that without being able to run and have a look to see what was going on inside DAX Studio, free community tool. So
yeah, indeed. So recently it happened. I was in one of the conversation, and one of the guy from the audience, he asked, what is the best tool to optimize DAX? So my straightforward answer, okay, just pick your DAX query, run it in the DAX Studio, and see what is the problem over there. And for me, that's the best part which we can do. And the guy said, no, I don't agree. We need some other tool. Don't you think so? We should have something more, etc. I said, do you have like complete knowledge about the DAX Studio? Because if you have, probably that question won't come into the picture. Problem is, which I see from my point of view, people they don't have the sufficient knowledge. They just block themselves not to dig down further or try to understand more, like you have explained the fusion concept over there, how we can just play around that code, and we can do hit and trial, or see how we can manage it to reduce the number of queries that we are sending to the data source, or how we can do that.
Well, even I'll jump back to DAX Studio. A really good technique that you can do is remember those earlier queries that we were running down here. You can go, okay, I'm going to run this query here and see how long it takes. And let's say it takes 20 seconds. I can comment out that line and rerun it and see, okay, it still takes 20 seconds, and comment out this one and say, all right, now it's only taking 2 seconds. Aha, I can focus on this measure because maybe that's the one, something inside this measure is taking a long time. And then I can explore into there and use old school techniques like commenting out to try and help me at least eliminate what it probably isn't, find what it might be, and then I can step back and start considering, all right, maybe I can solve this using a data modeling technique, or maybe an alternative DAX pattern might give us a more efficient result. I mean, this isn't unusual to DAX. There are plenty of technical domains when you're doing coding where you could write 6 different approaches, all different code, that produce the same result, but they might go about it a different way. Some might be really inefficient, some might be super efficient. This is nothing unique to DAX, and it's just a case of being at least trying them out. So
yeah, definitely.
So what I'm going to do is jump back to my slide deck where I've got a bit of a summary. So yes, you should absolutely use the appropriate tools. So we've talked about DAX Studio a lot. The other really good one is Tabular Editor, and a feature inside Tabular Editor which I love is called the Best Practice Analyzer, all completely free. You connect that to your model, you run it, and it just it spots patterns. It spots things that you might not realize that you could be doing wrong. You don't have to make any changes, but if you apply some or all of the suggestions in the Best Practice Analyzer, then what you might find is that your model is now in a healthier, better shape, and your queries run faster, your model's smaller, quicker to import. So use appropriate tools. We talked about relationships and storage mode. That was our phase 1. At least knowing what Fusion is kind of handy. I talked about the advanced iterator pattern. I used a time intelligence table right at the end to craft that where clause. That's getting quite artistic. I enjoy it, but man, it's helped me so much in the last few years and engagement after engagement. Definitely use variables. That's something I'm surprised I bump into a lot. People will reuse a measure many times in a simple calculation rather than just create a variable, assign a value to it once, but use the variable multiple times, especially for ratios and stuff that can cause performance headaches. As I said, should you apply these techniques all the time? No. You need to, remind yourself performance versus flexibility, code maintenance. In my solution, I've actually generated an awful lot of DAX to make this fast. Is that a good thing? Maybe not. What if I go on holiday for a couple of months, come back and look at it and go, how does this all work again? So maybe comments, good notes. But the techniques that we talked about work for import and direct lake too. So while I was using direct query to help demo what I was looking for in those server timings, exactly the same approach works if you've got a 100% import model or the exciting new direct lake storage mode that you get with Fabric now. So I'm not sure if you've got any other questions or you wanted to just touch on anything again. Sorry about the bumps, the issues at the start.
No, definitely. So I believe personally, these techniques are really important, and the way you have summarized them step by step, that really makes sense. And I believe all other viewers who are watching this video later on, they can definitely take a lot of from this one and they can start implementing that one. Overall, the simplest is the best answer always. So always focus on that. Start with your data modeling, the best practice analyzer, the way it's going to give you all the results. So you get actually where you need to focus on. Then you can also use over there the DAX Studio. You can check the query timings over there, storage engine and the formula engine and all. And yes, Fusion is a bit advanced, but if you are going to focus on that one, definitely you can go for that one too. So overall, I personally believe this is really very productive session. And if someone really wants to learn, there is a ton of information, to be honest. So I really appreciate your time, and thanks a lot, Phil, for coming on the Accounting Pro, sharing your knowledge and all. And I'm really looking forward that we can collaborate more into such sessions, and there we can define more, core topics which we can discuss, or something new that is coming on from Fabric side or something from the Microsoft side. We can also focus on that one.
Well, thanks again for inviting me, and for everyone watching. Enjoy your journey with DAX. It's exciting. You can do some amazingly powerful things.
Indeed. Thank you so much once again. And guys, if you want to follow and join Phil, please connect with him on LinkedIn. I'll provide you his LinkedIn profile in the description section. So please don't forget to connect with him and follow him, because he published a lot of things and he always at some conference. So you can also find, and if you can join those conferences, I really request you to join.
True. Yeah. FabCon EU next month, which I'm really looking forward to.
Yes, September, Sweden, right?
That's right.
Yeah, great. All right. Thank you so very much, Phil.
Thanks.
Really appreciate it.
See you later.
See you soon.
Bye-bye.
Bye-bye.